Okay, so we're multiplying polynomials today. This is day 2 and 3. Y'all know when there's multiple days, that just means you'll have a practice day. So tomorrow, the end of the period today and all of tomorrow will be a practice day. Sorry, it's like squirrel. I get distracted. Okay, anyways, so we're going to go over some. There are a lot, and I'm not going to do every single one just because it gets to be repetitious. Is that the word? I don't know. Repetitive? God, I'm making up my own words. Okay, but we are going to talk about all of them. So this first one is basic. What's happening here? We're multiplying. Okay, I want you to realize you treat coefficients just like normal. What are coefficients? The numbers in front. Okay, so 3 and 5. Well, what's 3 times 5? 15. Now, what do? Remember we did exponents right before break. I know you were like me and we were gone for 2 weeks. I still feel like my brain's not fully working. But what do we know about exponents when we're multiplying? You add them. Yo, that's all we're doing. Same concept. Now, what if a letter doesn't have an exponent? What can you put there? 1, because if it was 0, it wouldn't be there, right? Okay, so this is a to the first power. So what's a squared times a? A to the third power. What's c cubed times c to the sixth power? C to the ninth power. That's it. Okay? Don't let this be hard. Okay, so we have this term in front, just one term, right, in front of the parentheses. Okay, and what do we do when there's a term in front of parentheses? Distribute, yes. So we're going to take this whole term and we're going to distribute to the 1, 2, 3 terms inside the parentheses. Okay, because if I give candy to this class, is it fair if I only give it to one person? No, I give it to everybody. So that's what's happening. We're giving that first term to everybody on the inside. So we're going to multiply. What's 5 times 7? 35. X squared times x squared? X to the fourth. And y cubed times y, remember we put a 1 if there's nothing. So y3 plus 1 is 4. So there's our first multiplication set. Phones away. Okay, then we're going to multiply here. What's 5 times 6?
30.
Okay, x squared times x to the first power. Now, if you notice I have y cubed, but there's no y's here. So I'm just going to pull down y cubed, and then I have a z squared here, but no z here, so we're just going to pull down z squared. Now, one thing to remember, your variables should be in alphabetical. Is that I or an E? I don't even know, y'all. That's why I don't teach English. I'm making up my own word. It's wrong, but it's fine. Is it I? Okay, so X, Y, Z is in alphabetical order. Okay, and then what's 5 times negative 8? Negative 40. X squared, well, there are no x's over there, so I'm just going to bring down x squared. Y cubed times y. It's y to the fourth. And then there's no z's, so just z. Okay. Can anything combine? Are there any like terms? No, so there's your answer. So I want you to realize the second two terms, yes, they both have x, y, z, but what makes them not like terms? The exponent. It has to be the same variable and exponents to combine them, okay? The exponents are different, therefore we cannot combine them. Any questions there? Okay, what about this one? So again, we have terms in front of another set of parentheses, but we have two terms instead of a parentheses that has two terms, right? So binomial times a binomial. So what I call this is double distribution. Do y'all remember the acronym that y'all learned growing up for multiplying like this? You use it to cover food. FOIL. Do y'all remember that? First, outer, inner, last. Okay, that's where this acronym comes from. Okay, I don't really use the acronym. I just call it double distribution, and I take one term, distribute it, other term, distribute it, and then it's it. But it's the same thing as saying first, outer, inner, last. So first is m, and if I multiply it times the first in the other parentheses, what's m times m? M squared. Okay. Then outer, well, m is on the outside and 7 is on the outside. So what's m times 7? Okay. Then inner, well, 4 and m are on the inside. Positive 4. What's positive 4 times m? Positive 4m. And then last. This is the last of that parentheses. This is the last of that parentheses. What's 4 times 7? 28. Okay. When they're little binomials like this and they're both in standard form, highest degree first, the middle two should always be like terms. Okay, are 7m and 4m like terms? Yeah. Okay, there's no other m squared, so I can just bring that down. There's no other number without a letter constant, so we just bring that down. And what's 7m plus 4m? Huh? So positive 11m. Any questions with that? So again, we take that first term times the other first term. What's 3y times 3y? 9y squared. Don't forget the squared because y was twice. Okay, then what's 3y times 2? Positive 6y. Then we have this negative 2 times 3y, which gives me negative 6y. And we have negative 2 times positive 2, which gives me negative 4. What do you notice? Remember, we said the middle terms should always be like terms, but what happens there? They cancel. 6y minus 6y is 0, and you end up getting 9y squared minus 4. Okay, we call this the difference of squares. Because, what's another word for difference when you're doing math problems? Subtraction. Is there subtraction in the middle? Yeah, and is 9y squared a perfect square? Yeah, because 3y times 3y gives you 9y squared, and that's the same thing, right? And then 2 times 2 is 4, so 4 is also a perfect square. So it's the difference of two perfect squares. Does that make sense? This will help you in our next unit when we're going backwards and we're factoring. Do you remember factoring? Get excited, okay? So when you go this way, it's really good to remember this because it makes it 100 times easier if you just remember the rules, okay? What's different about 5 and 6? Is it binomial times binomial? No, it's binomial times trinomial. So we're going to multiply 6 times here, not just 4. Okay, so that's all the difference. I am going to show you another way to set these up, especially when you start getting into trinomials and stuff. It just helps. Like here is super simple because it's just the middle two that are always like terms. But when you get into trinomials and multiplying, you start to get like terms and they're separated, and then you have to look around, and it just gets kind of messy, okay? So I'm going to show y'all what I like to do. So I'm going to take my first term, and I'm just double distributing again. What's x times 2x squared? Technically, this is 1x, right? 1 times 2 is 2. What's x times x squared? X cubed, right? Then I have x times 10x, and it's going to be positive 10x squared. And then I have x times negative 4, which just gives me negative 4x. Everybody okay with that? So again, I'm going to double distribute just 3 times instead of 2 like on the last problem. So negative 3 times 2x squared is what? Negative 6x squared. Now, normally we would write that over here, right? But I'm going to set it up a little different. I'm going to line up my like terms. So I said negative 6x squared, so I'm going to put it under the other x squared, negative 6x squared. Then I have negative 3 times 10x, which gives me what? Negative 30x. See how it lines up with its like term? And then I have negative 3 times negative 4, which gives me what? Positive 12. And then you just add down. Well, this has no like term, so it's still just 2x cubed. What's 10x squared plus negative 6x squared? Positive or negative? So positive 4x squared. What's negative 4x plus negative 30x? If I take 4 and then I take 30 more, how many did I take? I took 34, so negative 34x. And then the 12 has no like term, so we just bring it down. There's your answer. Do you see what I mean as it organizes it a little better when you just line it up vertically? Okay, would it have been any different if I would have just written 2x cubed plus 10x squared minus 4x minus 6x squared minus 30x plus 12? Is that any different than what I just did here? No, because over here we would have combined the 10x squared and the negative 6x squared. Isn't that what we did? And then I would have combined the negative 4x and the negative 30x, which is what we did, and the two terms that had no like term, we would have brought them down. So for me, it just keeps it organized on your like terms lined up, so it's quicker and less looking around and getting lost, okay? Do you have to do it this way? No. If you prefer this way, that's totally fine, okay? Now, what's different about number 6? It's flipped. Do you think that changes anything? No. Okay, I'm not going to do the full problem, but I'm going to explain something to you. Okay, does multiplication order matter? No, what's 2 times 3? What's 3 times 2? So did it change anything? No, so if you prefer, could you put that k plus 2 in front? Could you work it out backwards? Could you do 3 multiplication, triple distribution, I guess? Yeah, it doesn't matter how you do this one. Don't let it throw you off. It's exactly like this one. Okay? But I'm going to skip it to save time, so y'all have more practice time, okay? What does squared mean? Multiplied twice. Okay, one thing I notice a lot on these, and I'll tell you, if this is a multiple choice question, it'll probably be one of your answer choices. People just go, oh, square everything inside. C squared minus 4. Is that the answer? I squared both of the things inside. No, it's not the answer. You have to write it twice. Okay, so c minus 2 times c minus 2. That's how you do these. Now, does it look just like one of those problems on top? Yeah. Okay, so what do I multiply first? C times c, and what's that give me? C squared. And then c times negative 2, which is just negative 2c. Negative 2 times c, which is just negative 2c. And what's negative 2 times negative 2? Positive 4. Middle two terms are alike, and I get c squared minus 4c plus 4. Don't let the squared throw you off. Just remember it means you have to write it twice. Okay? Squared means multiplied twice. So do you think example 8's any different? No, so I'm not going to go over it, but I am going to set it up. 3n minus 5 times 3n minus 5. That's how you would work it out. Okay? I am going to do example 9 just because it gets a little tricky, and there's another rule I want to talk about. Okay? So again, it's just squared. 6n plus 2p squared. 6n plus 2p squared. What's 6n times 6n? Okay. 6n times 2p squared. Well, what's 6 times 2? And now, remember, variables are always written in alphabetical order. Okay, so what comes first in the alphabet, N or P? Huh? N, so it's NP squared. 2p squared times 6n, again, is 12. And again, you write it in alphabetical order, so NP squared. The biggest reason behind that is because now we see that these are like terms. If you would have written it the other way, you might not have noticed that they're like terms because NP squared and P squared N look different. Does that make sense? Okay. 2p squared times 2p squared is 4p to the what power? 4th. The middle two are like terms. Remember, when you're combining like terms at the end, you're just adding coefficients. None of the exponents change. So this becomes 24np squared. Now, I want you to recognize something. Another tidbit is they're supposed to be written You're supposed to write it in highest to lowest degree. Do you remember talking about degrees yesterday? Okay, so this is a degree of 2. What's the degree of the middle? Who remembers? Bless you. Don't you add the 2 exponents? If there's no exponent, it's 1. What's 1 plus 2? So that's a degree of 3. What's the degree here? 4. So what's the highest degree? 4. So we're going to write that first. So it's 4p to the 4th power plus the 3rd degree goes next plus the 2 degree goes next. That is your proper way of writing it. Any questions with that? What's different about number 10? cubed, which is kind of gross, okay? What I want you to realize that means it's 3 times. Now, you do not want to multiply all 3 at the same time. You will get lost, okay? Because it becomes a mess. So the way we're going to do this is we're going to multiply 2 of them. We're going to ignore this third one, okay? And then we'll bring that one back. What's x times x? Huh? X times 3? 3 times x, and 3 times 3. I almost wrote 3. It's 9. Okay? The middle two combine, and I get x squared plus 6x plus 9. Now, does it matter if I put that x plus 3 in the front or the back? No, so I'm going to write it in the front. Now you'll multiply one more time to get your final answer. So I want y'all to try, and then we'll go over it together while I start attendance. Asif, are you trying? Try. Not sleep. Also, just so y'all know, I'll be selling Girl Scout cookies.
For real?
My daughter will be. So, if y'all want Girl Scout cookies, you know who to ask. Raven, Brooklyn, Sean, Vivian, Elizabeth, Anna. Jose, did you wake up late again? Okay, so what do you get? X cubed. Why don't we do it one step at a time? Plus 6x squared. No, you're good. Plus 9x. So that's my first distribution, right? Then my second one should be plus 3x squared plus 18x plus 27. Is that what y'all got the first time you multiplied? My x cubed does not have a like term. What's 6 plus 3? 9 plus 18. Does that match what y'all got? Cool. Okay, these last two are kind of gross. Example 12 is really not as bad as it looks. Why is example 11 gross? Because it's a trinomial times a trinomial. This is where I think lining it up like this makes life 100 times easier, because it's going to be 9 terms across your paper. Okay? But when you line it up, it just makes life 100 times easier. Okay, so we're going to take it one step at a time. What's 4x squared times 3x squared? 12x to the what power? 2 plus 2 is 4. 4x squared times 2x? Huh? Yeah. Sorry, I can't. Masks make y'all muffled, and it's hard for me to hear if I'm not, like, focused. Okay. And then 4x squared times negative 1 is just negative 4x squared. Okay. Then we have the 3x. What's 3x times 3x squared? 9x cubed. So I'm going to line it up with the other cube. 3x times 2x. So this plus 6x squared. And then 3x times negative 1 is just negative 3x. Okay, and then again, we have the 2. What's 2 times 3x squared? 6x squared. 2 times 2x, positive 4x, and 2 times negative 1. So this does not have a like term. So I get 12x to the 4th power. Now, what's 8x cubed plus 9x cubed? Positive 17x cubed. Now, what's negative 4 plus 6 plus 6? If you don't know, y'all, you can always type your coefficients only. You can't type the x squared here, but you could do negative 4 plus 6, and it gives me 8, so this is going to be a positive 8x squared. What's negative 3 plus 4? Positive 1x, and then bring down my minus 2. Here's our huge polynomial answer. Do you understand now why I think lining them up makes life easier? Because that would have been a big, long thing with ugly, it would have been gross, okay?